So let's talk about the different types of pigments. Pigments are the colored components of ink that can be produced in a lab or sourced from nature. But before we can dive into the definitions of organic and inorganic, we have to dispel a common misconception. If you think that organic means that a pigment is more natural, you're not alone, but this isn't correct. One of the misconceptions around organic pigments is that we automatically correlate the word organic to the classification of foods. Interestingly enough, the definition of organic and inorganic for pigments is quite different. Take this apple, one of my favorite colors of the Perma blend line, passion red. Both of these are organic, but not the same type of organic. With food, the terminology comes from not using chemicals, fertilizers, pesticides, or genetic modification. With pigments, these factors do not exist in the process. What makes a pigment organic is the presence of a carbon-hydrogen bond in its structure. Whether a pigment is organic or inorganic is not dependent on whether it's synthetically sourced, no matter the type. The majority of our pigments are synthetically produced, which allows for a cleaner end product. Our inorganic pigments are titanium dioxide, iron oxide, and carbon black. It's easy to locate high-quality sources of these pigments with good light fastness and high opacity. We use inorganics in many of our inks, including our flesh tones, because they are less vibrant in color than organics and have a high opacity, for example, in areolar and scar camouflaging procedures. Before we take the dive into inorganic pigments, we have to first hit the important terms in the manufacturing process. Light fastness is one of those terms. Light fastness is the measure of how quickly a pigment will fade with long-term light exposure. To test for light fastness, we use the blue wool scale. The higher the number, the better the light fastness on a scale of 1 to 8. In this test, a person takes several pigments within the same category, let's say a series of yellows, and leaves them exposed to a light source for an extended period of time, and provides the rating based on the fading observed. We use this as just one of the characteristics for choosing the pigments for our inks. Let's start with forest brown. It contains red, yellow, and black pigments. Contrary to popular belief, if yellow, red, and black all have light fastness ratings of 8, this doesn't mean that they will all fade at the exact same time. Different colors have different fading profiles. Black and blue pigments have the longest lifespan, and yellows have the shortest. The point of wanting a high light fastness rating is so that there is no degradation of the color throughout the color's lifespan. Inorganic pigments have their own classifications to determine how and where we use these colorants within our inks and the manufacturing process. A compound to note as we discuss inorganic pigments are oxides. Oxides contain at least one oxygen atom and one other element in its chemical formulation. The following are the color groupings of oxides we use in our pigments. For white pigments here at Permablend, we use titanium dioxide, or TiO2, because of its abundance and superiority in tinctorial strength. While TiO2 can be sourced from different origins, we source from rutile. There's also colored pigments, and they're synthetically sourced cosmetic-grade pigments. Examples include red 101 and yellow 42, also known as iron oxides, occasionally also referred to as mineral-based pigments. For black pigments, we use black iron oxide, but because of its poor tinctorial strength, for some colors we will use carbon black, a non-oxide pigment with a higher tinctorial strength. There is another category called specialty pigments, which include cobalt blue and chromium green oxides. We do not use specialty pigments in the Permablend line. Due to increasing regulations around the world, we must constantly reevaluate the quality of our raw materials and the sourcing of those materials regarding sustainability. The main objective of Permablend's research and development is to continually identify and develop safe and effective quality pigments that meet all regulatory mandates. Here are the typical characteristics of inorganic pigments: less vibrancy, low tinting strength, high opacity, great light fastness, low molecular weight, large particle size, prone to agglomeration, and lower costs. So do you know where Permablend got its name? Perma comes from permanent, makeup, and blend comes from our introduction of organic and inorganic blends in inks. Permablend was the first to do this. The usage of mixing organics with inorganics really revolutionized the quality of healed results and durability of inks in the industry. With pigment blends, the organics are able to give the vibrancy that inorganics lack, but maintain the opacity of the inorganics, providing the perfect blend. Hybrid is a new phrase now in the industry to describe these blends. All of our organics are synthetically made, meaning that they are lab created in a controlled environment. Organic pigments are all comprised of carbon and hydrogen bonds. An organic pigment must have both elements in order to be considered organic. Everything living is carbon-based life form. Take this martini, for example. The alcohol is organic. The ethanol within it contains a carbon-hydrogen bond, but the glass is inorganic. Glass is made from sand, also known as silicon dioxide. It's just water. Typical characteristics of organics are vibrant color, strong tinting strength, varying opacity, varying light fastness, high molecular weight, small particle size, prone to agglomeration, and higher costs.